All right, so today we're solving trig equations. All right, let's go ahead and let's just get to it. So let's go ahead and let's kind of review a little bit of what we were doing before. We'll just do this kind of through examples. Let's say we have 2 sine x minus 1 is equal to 0. Okay, now when we're solving this sort of equation, we're looking for answers that there are 2 kinds of answers. One, we're looking for answers where, let's say, x is between 0 and 2 pi. Okay? If we're bounded by this, then we're only looking for the angles that are within 1 revolution. Otherwise, we have to come up with kind of a general answer, and we'll talk about that here in a moment. So let's go ahead and let's solve this like we would any other equation. So we're going to isolate the trig expression, and sometimes this gets tricky. But let's go ahead and let's first move the 1 to the other side. We'll divide by 2. And so we're looking for the angles where the sine of x is equal to 1/2. Okay? So just to kind of refresh you with your quadrant 1 values, okay? In quadrant 1, anything with a denominator of 6, denominator 4, denominator 3, this sine, cosine, tangent, okay? This is as easy as 1, 2, 3. Everything's over 2 and everything has a square root. So just to kind of refresh your memory then, square root of 3 over 2, square root of 2 over 2, 1/2. Again, 1, 2, 3. It's as easy as 1, 2, 3. Then we have radical 3 over 3, 1, and square root of 3. All right, so where is the sine equal to 1/2? Well, the sine is equal to 1/2 at pi over 6. And so x is equal to pi over 6. But we know, okay, all students try calculus, okay? When we have this, there's going to be more than one answer. We know there's going to be a pi over 6 in 2 of the quadrants. Where is the sign positive? The sign is positive in quadrants 1 and 2. So pi over 6 in quadrant 1, that's easy, it's pi over 6. Pi over 6 in quadrant 2, if you recall, is 5 pi over 6. So if we're only looking for angles between 0 and 2 pi, our answers are pi over 6 and 5 pi over 6. Okay? Quite easily done. Alright, so let's come down and let's look at, maybe some of these get a little bit harder, maybe they don't. Let's see. Alright, suppose we have sine of x plus radical 2 is equal to negative sine x. Sorry about my handwriting, it's been a while. Okay? So when we look at this, we want to isolate the trig expressions. We can move these things now. We're not bound like the last section where we had to work one side only. Now we can actually move sine x from one side to another through addition or subtraction. So on the left side, this gives us 2 sine x's. We'll subtract the square root of 2 from both sides, and we end up with 2 sine x is equal to negative radical 2. Okay? We're almost isolated. We divide by 2, and we get sine of x is equal to negative square root of 2 over 2. Where is the sign negative? Quadrants 3 and 4. We know they're going to, assuming that we're still between 0 and 2 pi, okay, we're going to end up with 2 answers again. We know that the sine is equal to the square root of 2 over 2 at pi over 4. So we're going to have 2 pi over 4s. Okay? Pi over 4 in quadrant 3 is what? That's right. It's 5 pi over 4. And pi over 4 in quadrant 4 is 7 pi over 4. So our 2 answers would be 5 pi over 4 and 7 pi over 4. Right. Example 3. Okay? 3 sine squared x minus 1 is equal to 0. let's get the tangent squared x by itself. Add 1. Divide by 3. Oh, we got to get rid of a square root. What's the difference? What's the opposite of squared? I asked that to a class once and they said circle. In this case, let's go with square root. And so the tangent of x has to equal plus minus square root of 1 over the square root of 3. Not allowed to have a square root in the denominator of a fraction. So let's go ahead and let's rationalize right away, and we end up with radical 3 over 3. Okay? Where is the tangent equal to square root of 3 over 3? At pi over 6. So x is going to be pi over 6. But here's the problem. We have a plus or minus pi over 6. All students try calculus. Tangent is positive in quadrants 1 and 3. Tangent is negative in quadrants 2 and 4. So with a square root comes this plus or minus. That also indicates that we're looking for 4 answers. 2 of them positive, 2 of them negative, if we're bound by 0 to 360 or 0 to 2 pi. So x is going to be any pi over 6 in all 4 quadrants. So that would be pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Those would be all of our answers. Okay? Look at that. Isn't that pretty? Okay. All right. Let's do example 4. All right. Suppose we have cotangent x times cosine squared x is equal to 2 cotangent x. Now when I'm doing these problems, my first goal is to get them all into the same trig function. Okay? Unless they're separated by multiplication, and that's fine. In this case, we're going to make, let's go ahead and get everything on one side. Okay, so we got everything onto one side, and let's factor out the common factor, which in this case is cotangent x. Sometimes when you do this, it allows us to solve 2 equations. Okay, so when you look, we have the cotangent of x. Okay, we factor it out by dividing. It's the opposite of the distributive property. Okay, and what we have left is then the cosine squared minus 2, because we took that cotangent out. Separating each, we have cotangent x is equal to 0. Okay? Well, cotangent of x is equal to 0 when x is equal to pi over 2. Cosine squared x minus 2 is equal to 0. Let's see, it means that cosine squared x is equal to 2, which means that when we when we take the square root of this, we have the cosine of x is equal to the square root of 2, plus minus, of course. So the question then is, where is the cosine equal to the square root of 2? And the answer is never. Because remember, cosine only goes between 1 and negative 1. Square root of 2 is approximately 1.414. So the cosine will never be square root of 2 ever. Okay? So our only answer then is when x is equal to pi over 2. That's when the cotangent is equal to 0. Now remember, we were assuming that we're looking for answers between 0 and 2 pi. Okay? We're not looking for answers outside of that yet. Okay? We'll talk about that in a moment.